Hey guys, welcome to CPM 3. This is Module 1, Lesson 5. This might be a long lesson because we do have 6 pages to get through in notes here. So I'm going to go through the front part of this pretty quickly because this is kind of a review from CPM 2. And so a lot of this should be familiar. And I guess if it's not, you can pause this video and rewind it so it's a little bit slower. But I am going to kind of blaze through this very first part here. So the first thing is we've got a couple definitions we need to go over. The horizontal number line, that is called your x-axis. And so you can see your x-axis right here. So it's this horizontal thick black line that's going horizontally. So then your vertical line is called your y-axis. So y-axis here, and so there's your y, that other thick black line. The point where the x-axis crosses the y-axis with a measure 0, 0, this is called your origin. So origin right here in the very center in the middle. And then the axis divides the plane into 4 quadrants, 4 regions called quadrants. These quadrants do have numbers. So notice you've got quadrant 1, 2, 3, 4. And so we're going to go over how to plot this. But basically this is your positive, positive. So when you have positive, positive, that's your quadrant 1. And then everything else goes counterclockwise. I think that's the part we mess up the most on, is that we think it goes like a clock, but it goes backwards. Okay, so to graph the point corresponding to a particular ordered pair, you're always going to start at the origin, so you're always starting at the middle. You are going to move x units to the left or right along the x-axis first. So right if it's positive, left if it's negative. And then from there, move up or down along the y-axis. So up if it's positive, down if it's negative. We're going to get into slope in a little bit later. When you use slope, it's the exact opposite way you're going to move. So to kind of help us on how to plot points, we're going to remember OU. When you plot, you need to go over, side to side, before you go up or down. Okay, so you're going over side to side before you go up or down. And so you'll hear me a lot of times say over before up, sort of thing. So on this first one here, I'm going to zoom in. I really hate zooming in, but I'm going to zoom in here. Example 1 says, for the following, plot each ordered pair, state in which quadrant, if any, each point lies. So we'll start here with A, B, and C. All right, so for A, we're going 5, 3. So 5, we're going to go OU. That means over side to side. 5 means positive right, and then up or down 3. 3 is positive, so up 3. So from the origin, we're going over 1, 2, 3, 4, 5. And then up 1, 2, 3. So your point is right here. And I'm going to get rid of all those lines, but that's how you're counting since you can't really see my pencil. You're going over 1, 2, 3, 4, 5. Then from this point here, you're going up 1, 2, 3. So we are only making a dot 1, 2, 3, 4, 5, 1, 2, 3 at right here. And then we can list that as A. On B, now we're negative 5, 4, so we're still using OU, over side to side before we go up or down. So negative 5 means we're going sideways to the left. And then 4 means we're going up. So we're going 1, 2, 3, 4, 5, then 1, 2, 3, 4 up. So right here. Oh, we're also supposed to say what quadrant this is in. So A is in quadrant 1, and then remember it goes counterclockwise. So this is quadrant 2. C is -2, -3. So -2, OU, over side to side. We're going left 2, and then up or down, -3. Since 3 is negative, we're going to go down. So it means we're going 1, 2 over, 1, 2, 3 down. 1, 2 over, 1, 2, 3 down. This is C, and that is in quadrant 3. Okay, over here on D. D is 6, -1. So OU over side to side, a +6, that means to the right. And then up or down, -1, since -1 is, well, negative, we're going down 1. So from the origin, 1, 2, 3, 4, 5, 6, and then 1 down. So that is D, and that one is in quadrant 4. These ones here with zeros seem to be the most confusing. You just got to remember your OU. If it is 0, 2, that means you're going 0 from the origin, you're going 0 left or right, and then you're now going a +2, so we're going just 2 up. So 0 left or right, then 2 up. Now, because that is on an axis, it is not in a quadrant. So that's why I said if any, state what quadrant. So technically you don't need to write anything on here, but this is your x-axis, this is your y-axis. So if you wanted to write something, that would be your y-axis. And anytime you have 0 for your x, that's always going to be on the y-axis. So then opposite on F, you got -4, 0. So that means OU, we're going -4 to the left, since it's negative. And then 0, 0 up or down. So from the origin, 1, 2, 3, 4, but then 0 up or down. So, same thing, it's not really in a quadrant since it's on an axis. So if you wanted to write anything, this would just be your x-axis. And same thing, if you ever have 0 for your y, it's always going to be on the x-axis. All right, page 1 done. Page 2, determining whether an ordered pair is a solution. So, it says right here, an ordered pair is a solution of the equation in 2 variables if replacing the variables by the value of the ordered pair results in a true statement. So something like 17 equals 17. That's a true statement. 17 does equal 17. If you get anything else, like let's say 17 equals 16, those are not equal, and so that means that's not an ordered pair. So these are almost like 3 problems in one. So on this first one, when I use 6, 0, six is your x coordinate, 0 is your y coordinate. So that means you are plugging in this equation here a 6 for your x and a 0 for your y. You have 2 variables, and they're telling you what both of those variables equal as an ordered pair. So you've got x minus, my x is 6, so 6 minus 2 times y, my y is 0. And we want to know, does that equal 6? So 0 times anything is 0, so that goes away. So we're going to get 6 equals 6. That is a true statement. So is this ordered pair a part of the solution? Yes, it is. So let's try again. Now we have 0, 3. So this is your x, this is your y. So plug them in accordingly. You got x minus, so 0 minus 2 times y. 2 times my y is 3. And I again need to know, does that equal 6? So 0 kind of goes away. If you have 0 minus nothing, it's still that number. So we have negative 2 times 3, which is negative 6. Does negative 6 equal 6? No, it doesn't. So is this an ordered pair, part of that linear equation? No, it is not. Okay, I'm going to have to do this one kind of small to fit this one in. But my next ordered pair, one second, guys. Okay. All right, my next ordered pair is 1 comma negative 5 over 2. And I'm definitely not going to have room. Okay. I'll tell you what, for the sake of room and time, B is the exact same, so I'm not going to do B in this video, and so I'm going to use this room down here for this one. So we've got 1 negative 5 over 2. Let me skip this over just a little bit more. Okay. Right off the bat, you guys hate negative 5 over 2. Change it into a decimal, guys. If you put in your calculator negative 5 divided by 2, you're going to get a perfect, not really perfect, but it's a decimal, but negative 2.5. So let's use that instead when we're plugging that in. So we've got, I'm still using this equation up here, x minus, my x is 1, minus 2 times y. My y is this negative 2.5. We changed it from that decimal. And again, does this equal 6? So we've got 1 negative 2 times negative 2.5 is going to give me a positive 5 equals 6. Now, really and truly, you should be able to tell from there, 1 plus 5, yes, that equals 6. That is a true equation. If you want to stop right there, that's perfectly fine. If you want to take it one more step and get all the way to 6 equals 6, I'm fine with that too. Okay, I don't care. Main thing is, though, that yes, this is an equation. Okay. Now, you guys can try B if you would like to. And if you want to try it, check your answers. You should get no for the first ordered pair, then yes, and then yes. Okay, but I kind of ran out of room. It's the exact same thing as part A, and so this will also not make me squeeze everything together, make this video a little bit shorter. So C, we got x equals 1/4 y. You guys hate the fraction. So when you multiply your fractions, 1 times y is either 1y or just y. So if you would like to make this easier to plug this into, rewrite this problem as x equals y over 4. Okay, that's the exact same thing, since 1 times y is y. Okay, so my first ordered pair is 1, 4. So one is my x, 4 is my y. So when we plug it in, you got x equals, my x is 1, so 1 equals y over 4. My y is 4, so we get 4 over 4. And the question is, do these equal each other? Well, 4 divided by 4 is 1, and so we do get 1 equals 1. So then this one here is a yes. Go on to the next one. My next ordered pair is 8, 2. This is my x, this is my y. I'm going to use this equation again. So you got x equals, my x is 8, so 8 equals y over 4. My y is 2, so we get 2 over 4. Or right here I can already tell it's not equal. The only thing you can kind of do is kind of simplify it. 2 over 4 is 1/2, so you can go 8 equals 1/2 instead of 2 over 4, but either way, these are not equal, so this one is a no. And then lastly, 0, 0. Still using this equation. So x equals, which is 0, y over 4. My y is 0, 0 over 4. 0 divided by anything is 0. So we get 0 equals 0. That is a true statement. So that makes this one a yes. That is a solution. All right, let's turn the page. Page 3. Now they're going to give me part of my equation, or part of my ordered pair, and I have to solve for the other one. So here, in this first one, they're giving me my x coordinate. I need to solve for y. So use this equation here. In place of this x, we're putting in our 0. So we've got 3 times 0 plus 2y. I don't know what y is. It's literally what we're solving for. So 2y equals 12. So solve. So anything times 0 is 0. So I'm left with 2y equals 12. Divide both sides by 2. And we get y equals 6. So the other portion of this ordered pair is 6. So do the same thing with the other 2. Now I don't know my x, now I know my y, so plug in this 0 for y, solve it for x. So in this equation, we've got 3x plus 2 times y, my y is 0, equals 12. So get x by itself. Again, 0 times anything is 0, that goes away. So we have 3x equals 12. Divide by 3 to get x equals 4. So that's the rest of this ordered pair. And last one, they're telling me x is 2, so solve this for y. So we've got 3 times my x, which is 2 plus 2y equals 12. So this time nothing cancels out, but it's not a big deal. 2 times 3 is 6. So we got 6 plus 2y equals 12. Get y by itself. So we're going to subtract this 6 over. We get 2y equals 6. Divide by 2. And we get y is 3. B is the same thing, but I know you don't like that fraction, so I figured we would do one with the fraction. So, on B, x equals negative 1/3 y. Same thing as the previous page when we made this change here, make the change. So, 1 times y is y, and then negative 3 times 1 is negative 3. You're basically just moving this y up, keeping everything else the same. Now you could also keep that negative neutral the way that negative is neutral here and make that negative y over 3. But you'll see that it makes the solving process a lot easier if you choose for that negative to go down to the bottom. So we're going to make that y over negative 3. Okay, so my first ordered pair, I know y is 0, so we got to solve this for x. So I'm using this equation, the one we rewrote, don't know x. So we got x equals, my y is 0, so 0 divided by negative 3. 0 divided by anything is 0. Okay, now I know my x is 4. We're solving for y. So using this, x equals, x is 4. 4 equals y, that's what we're solving for, divided by negative 3. So this one takes a little bit of solving. Get y by itself. We're going to multiply that negative 3 over. My negative 3's cancel. We're left with negative 12 equals y. So here, I don't think I'll be able to fit that one in. We got negative 12 there. And then my last ordered pair, we know y is 9. Solve this for x. So using this equation, x equals, we don't know. So x equals y is 9. 9 divided by negative 3. Well, 9 divided by negative 3 is negative 3. So those are our ordered pairs. Now, we're about to use this exact same thing. It's just going to look like it's in a different format, but we're doing the exact same thing we just did on these two examples. So keep that in mind. This page here is just kind of for your information sort of thing. There's not really a lot to do. You have this linear equation in two variables is ax plus by equals c. When you have a linear equation, it's going to graph a straight line, and so that's what we're about to do, is actually graph these lines. It tells you here that this is considered standard form, but notice that in the form, the understood exponent on both x and y is 1. So if you don't see an exponent, that's known to be ax to the first, by to the first. So you have some example here of linear equation in two variables. Notice that you have an x and a y. You have an x and a y, even though on this one, they're on the same side of the equation. That's why it's called standard form. On this one, they're on opposite sides of the equation, but that doesn't matter. There's still an x, there's still a y, and they're both to the first power. Same thing here. You have an x, you have a y, all to the first power. Even this one here is considered linear equation as long as you have at least one. So even if you have something like x equals 5, still linear. You have x to the first power, this one y to the first power. Some non-linear examples. This would be something like x squared plus y equals 4 because of this squared. Any other exponent, so something like y cubed equals 7. Okay, or if you're missing both of your variables, it seems silly, but if you're missing both of your variables and you have something like 14, okay, that's not linear. So we're going to start graphing, and it says right here, from geometry, we know a straight line is determined by just 2 points. And what that means is, if I put a point here and a point here, I can draw a straight line through them. If I have a point here and a point here, I can draw a straight line through them. You only need 2 points to make a line. Graphing a linear equation, 2 variables, then requires that we find just 2 of its infinitely many solutions. Once we do so, we plot the solutions and draw a line connecting the points. Usually, we find a third solution as well as a check. And you will do just that. Okay, we will always find 3 points unless we're finding intercepts. So that's a whole different deal. So, here are the steps. You are going to find 3. It's underlined for you. Find 3 ordered pair solutions. Choose a value for one of the variables, x or y, then solve for the other variable. Plot the solution, draw a line connecting the 3 points. Okay. You have this little helpful hint down here that says all 3 points should fall on the same straight line. If not, check your ordered pair solutions for a mistake. So we're finding 3 to make sure they all line up. If one of them don't line up, that means we've made a mistake somewhere and we'll have to go through and fix it. So here we go. Example 4. We're going to start graphing lines. For each equation, find 3 ordered pair solutions by completing the table, then use the ordered pairs to graph the equation. So you will sometimes have this box sort of already set up for you. That's nice when they do it, but as you can see, not always the case. So first one's a little bit easier. Now, right from the beginning, I know you guys don't like the fraction. Rewrite this fraction the same way we did here. And here. So instead, we're going to make this y equals 1 times x is x over 2 minus 5. And actually, I'm just going to rewrite this. I don't like the way that looked. My OCD's flaring. Sorry, guys. Right down here. This is the same as y equals x over 2 minus 5. Okay. So this is the same thing as them saying on 2 pages ago that you have -2 comma something and you're finding this something. We know that the x is -2, so plug that into this x and then solve for y. So that means we have y equals x over 2. My x is -2, so we got -2 over 2. And then -5, so -5. So simplify. Y equals -2 over 2 is -1. Bring down your -5. -1 minus 5 is -6. So -6 goes in here. Do the same thing with this 0. 0 is for x. So I'm using this equation again. You've got y equals x over 2. Your x is 0. So 0 over 2. And then bring down your -5. Well, 0 divided by anything is 0, so that goes away. So we're just left with y equals -5. And then this one down here. Now this is the first time that we know y. Y is 0. So in place of this right here, we've got 0 equals, and then now the rest of it, since I'm solving for x. X over 2 minus 5. So this one takes a little bit of algebra, so solve it. We're going to add over the 5. So we've got 5 equals x over 2. Opposite of divide by 2 is to multiply by 2. So we've got 10 equals x. So those are my 3 ordered pair solutions. So now graph them. So my first one, -2, -6. So from the origin, we're going -2, remember, over side to side. So from the origin, 1, 2 in the negative direction, the -6. So down 1, 2, 3, 4, 5, 6. Okay, so now let's graph 0, -5. So OU, we're going over side to side 0, and then down 1, 2, 3, 4, 5. Now, we would graph the third one, and more times than not, this is not going to happen. But I don't have 10 to go over, so I can't really go over 10. So we're just going to graph these 2 points. But every single other time, all of these points should fit on this graph. So now just connect the lines, and this really makes my OCD go crazy since I can't draw a straight line. But your line looks something like this. Now, back on this page here, it said that you have infinitely many solutions. What that means is we picked 3 points to put on this table to make the line. But all of these points here are solutions. So these are not the only 3 we could have or should have picked. There are, even points in between points on this line. So the biggest question it seems like I get whenever we start doing this is because now we have to make our own chart here, right? And so it's how do you pick these numbers here? You can literally pick any numbers. There's not a right or a wrong as long as it makes that straight line. Okay, so that's why we pick 3 to make sure we're doing this correctly. So on B here, make your chart. We've got X, Y. Actually, let me put this in black. X column and a Y column, and I need 1, 2, and then 3 points there. So, pick some easy numbers. I always like to put 0 in for X and 0 in for Y. Those are the easiest ones there are. So if I start with this first one of when X is 0, put it into this equation here. So we've got 3 times 0 minus 6y equals 3. Well, 0 times anything is 0. So we got 6y equals 3. Divide your negative 6 over, and we get y equals negative 1/2. Usually this isn't going to happen, so of course it does on the first one we do, but that's perfectly okay. Decimals and fractions are included on this number line, so don't let those, freak you out. So I've got negative 1, or negative 1/2 here. So now let's go to when y is 0. So we've got 3x minus 6 times 0 equals 3. Again, 0 times anything is 0. That cancels. So I'm left with 3x equals 3. Divide by 3, and we get x to be 1. So that's my second ordered pair. So this is enough to graph this equation, but we want 3 to make sure we are doing things correctly. So to kind of prove my point, we're kind of going in an order here. We got 0, 1. We could definitely put 2 here. 2 would work. But you can put any number you want. So let's just get crazy with it. And let's skip 2, and let's just jump right on to 3. You're still going to get the same thing. So now, in place of x, put in your 3, and let's solve for y. So I've got 3 times 3 now, minus 6y equals 3. 3 times 3 is 9. Opposite of a positive 9 is a negative 9. So I got negative 6y equals negative 6. Divide both sides by negative 6. And we get y to be a positive 1. So now just plot them. So I'm going to kind of zoom in here so you guys can see it a little bit better. My first point was 0, negative 1/2. And so just so you guys know, I'm plotting these points right here. Okay. But I can't see them on my screen anymore, but those are the points I'm plotting. So we got to remember OU. 0 left or right, so I'm not going left or right, and it's negative 1/2, so I'm not going down negative 1. I need to go right here in between, so negative 1/2. Then we had 1, 0, OU. We need to go over a positive 1, 0 up or down, so that's my point. And then 3, 1. So from the origin, we're going over 1, 2, 3, and then up 1. So you can see here, they're on a straight line. So this is my line. But again, there's so many other points, right? All of these points here, so if you didn't pick 3, you could have picked anything. You could have got negative 2, negative 2 right here. There's all of these infinite many points. So just because I picked 0, 0, and 3 to plug in, that's not the only way to form this exact same straight line. Okay. And then here's another one. This one's going to go a lot quicker because this one is what I like to call user-friendly in how to plug these in. So on this one here, we've got our X, Y column. We still need 3 points. Because this one is solved for X, the easiest thing to do is to plug in numbers here. Now you're just doing 5 times whatever number you're wanting to plug in. So if I want to do -1, no, let's start with an easier one, right? Let's go 0, 1, -1. Okay. When I start with this one here, we've got X equals 5 times 0. 5 times 0 is 0. So we get 0 here. You got X equals 5 times 1. 5 times 1 is 5. And then Y is -1. So we get X equals 5 times -1. 5 times -1 is -5. When it is solved for a variable, it's a lot easier to plug into the other one. That way you're just getting that number. You're just evaluating the other side. You don't have to move anything around. So, plot these points. 0, 0, that's your origin. 5, 1, OU. We're going over 5 and then up 1. So over 1, 2, 3, 4, 5, up 1. And then -5, -1. So I'm going over -5 and then technically down 1. So 1, 2, 3, 4, 5, down 1. So we've got another straight line here with those points. So draw your line through it. And I haven't said this, but you do want to make sure you put arrows on these because it doesn't just stop right here. These lines keep going infinitely in both directions. All right, and now our very last page here. You got X equals 4 and Y equals -1. These are the easiest ones ever. When you only have one variable, it is either a horizontal line or a vertical line. It's not diagonal in either way. Still make your chart. So, here's my XY little T-chart. We still need 3 points. Because it is telling me here that X is 4, X is always going to be 4 no matter what, along your X column, we're putting 4 all the way down. Now, because there's not a Y in this, makes no difference what we put in here. I always pick 0, 1, 2, but you can pick any numbers you want. So now just plot these points. So 4, 0, we're going 4 over, 0 up or down. So 1, 2, 3 from the origin. 1, 2, 1, 2, 3, 4. 4, 1 means we're going 4 over, 1 up. And 4, 2, 4 over, 2 up. here is my line. So when you get x equals a number, it's a vertical line. Okay, and it's right here on that x-axis where x is 4. So opposite on this one. When I make my t-chart here, and I need my 3 points again, now this time, y is always going to be -5. So I'm going to put -5 all the way down here. There's no x in this equation, so put whatever numbers you want. I always put 0, 1, 2, but to kind of prove a point, let's go -7, 10, and 2. Okay, doesn't matter. So, OU, I'm going to go over -7 and then up, or in this case, down, -5. So, from here, and actually, I don't have 10 on here. I need to switch this one. Let's go to a 3, and then we'll make this one 6. Okay, still OU over -7 down 5. So from the origin, we're going 1, 2, 3, 4, 5, 6, 7, then down 1, 2, 3, 4, 5. Three, -5. Over 3, down 5. 1, 2, 3, 1, 2, 3, 4, 5. And then 6, -5 over 6, down 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So my line is horizontal. And so if you picked your 0, 1, 2, then you would have had dot, dot, dot right there. Okay, and then we're going to end this fun and exciting lesson with a word problem. It says solve. The value of a house X okay, let me start. The value of a house Y in value X years after purchase by the formula Y equals 75,000X plus 120,000. Complete the ordered pair. So this is what we've been doing. This is your X, solve for your Y. So we've got Y equals 75,000 times 5 plus 120,000. Now you can do this part by part. We can multiply 75,000 times 5 is 37,500 plus 120,000. Add them together. We get Y equals 157,500. So this is my Y, so that means my ordered pair now is 5, 175,000. 157,000, sorry. Okay, so that one we've been doing. This one, part B, seems to be a little bit harder. Now we need to use that information. We need to use the formula and the information about the formula. Bless me, sorry. To write a sentence explaining the meaning of this ordered pair. What did my X represent? Years. So in 5 years, what does this mean? What does my Y mean? That is the value of my house. My house will be worth, we're talking about money, so $157,000. There is one more thing we need to talk about. So we've got the X, we've got the Y in there. We need to talk about this number here. That number is how much I paid for my house to begin with. So in 5 years, my house will be worth $157,000 if I bought it for $120,000. All right, pause this video, rewind it. Let me know if you have any questions.